All right, here we go. Chapter 2. We're starting to talk about probability, which is really what we'll be looking at most of the rest of the semester. Is essentially we're kind of introducing probability. We'll talk about counting, which obviously not counting 1, 2, 3. All right, different types of counting. But anyway, first section is kind of just an introduction to probability. So first off, basic definition of probability. Probability of a set of outcomes is a number that represents the likelihood that one of the outcomes in the set will occur on a performance of the experiment. Okay, most people understand that. Okay, important other definition, an event is a subset of a sample space of an experiment. Okay, so we're going to look at an example of that here on the next slide. All right, so say the Cubs are playing a 3-game series with the Dodgers, and we're noting just whether or not they win the game. Okay, so win or lose. We want to list the outcomes of these following events. So first off, Cubs win all 3 games. So what are the outcomes? That's just win, win, win. Nothing complicated there. Okay, won all 3. Okay, another outcome or another event. So A is an event. They win all 3 games. B is a different event. And I want to write the outcomes of that event. So Cubs win at least 2. So that means they could go win, win, loss, or they could do win, loss, win if they lost the second game, or they could lose the first game, win the second 2. Okay, but it's at least 2, so you could also include if they did win all 3. It's still part of that event. Okay, so there's 4 ways that can happen in that event. Okay, and the last option, they win exactly 2 out of 3. All that is just those, the ones that had 2. All right, so nothing crazy there, just listing outcomes in events. All right, that becomes important when we start actually talking about calculating probability. Okay, so sorry about that. Some formalities here and some different symbols and terms that you need to make sure you know. So first off, another definition, probability of an outcome is also called the weight of that outcome. So if you hear weight of an outcome, that just means the probability. So an example, this is something that you're going to see, and this is going to look kind of familiar. Problems that we see like this, kind of familiar to ones we did where we had like the number in a set. If we knew like the number in the set added to like 50 and one was twice as much as the other and so on. It's kind of going to be the same idea here. So we're going to say we have an experiment, sample space S, and our outcomes, so outcome 1, outcome 2, outcome 3, and so on, up to a certain number of outcomes. Okay, in assignment of probabilities of these outcomes, we use W to represent the weight of each outcome or the probability of each outcome. So the reason why you see W is that stands for weight, which is a probability. So all these W's are probabilities. So basically, outcome 1 is going to correspond to the probability of outcome, let's just use this. So the weight of any of them, so in this case, the weight of, let's just say I, that just corresponds to outcome I. So it's the probability of outcome I. So if I had outcome 1, that would be W1 would represent the probability of outcome 1. So some things with probabilities or weight. It's got to be between 0 and 1, right? It can equal 1, it can equal 0. Obviously, we can't have a negative probability. We can't have a probability of 1.4, right? So 0 to 1. And then this, okay, this is going to come into play quite a bit. All right, and it seems obvious. What this means is all of our probabilities in a certain situation here, or in a certain experiment, I should say, all the probabilities in the experiment will add to 1. Okay, which makes sense. All right, if I flip a coin, I have 2 options, heads or tails. It's 1/2 and 1/2. Those add to 1, right? That's the experiment. Those are the probabilities at after 1. Okay. And there's some notation down here at the bottom you're going to see in your book. If you see this, it says what's the probability of that, of outcome 1, and it has a comma, outcome 2. All that is you just take the probability of outcome 1 plus the probability of outcome 2. So W1 plus W2. All right. So when you have it in the brackets with the commas, that just means you're adding those probabilities of the outcomes. All right. Moving on. All right. So an example using that. This is the one I was talking about. It's going to be kind of similar to those ones where we're finding a number in a set. So we have 5 outcomes. So W1, W2, W3, W4, W5. We're told some information. We know what W1 is. We know what W2 is. We know W3 and W4 are the same. And we're also told what W5 is. We want to find W4. So we set them up. We know, because these are my 5 outcomes, so all those added together add to 1. And then once I have that, so that's where it kind of looks similar to the stuff from last chapter, we can start substituting what we know. So first off, W1 is 0.23, so put that in. W2 is 0.14. Okay, we'll get to 3 and 4 in a second. W5 is 0.29. Okay, and it says 3 and 4 are the same. What we're wanting is W4, so we'll just substitute W4 in for the W3. So it would be plus W4 plus W4. Now, if you look, I've got one variable in my equation to solve for. All right, so combine those, that gives me 2 W4. If we take the 0.23 plus 0.14, so that's 0.37. 0.37 plus 0.29 is going to be 0.66. Okay, and solve for W4. So subtract 0.66. Okay, and then I'm out of room, but we would divide by 2, so that means W4 would be 0.17, and that's what we wanted. All right. So that is an example of finding the probabilities when we know we have a certain amount of outcomes. Like I said, kind of similar to those ones we did last chapter, just now we're using probabilities instead of actual whole numbers. All right. Okay, some other stuff, probability here, and we'll get another couple examples and we'll be done. So if we have an event E, it's a subset of S. Okay, so it's our sample space S, our event is a subset of that. Probability of event E, we denote that just PR parentheses E. You might see me sometimes write it this way. Okay, sometimes I do that because AP Stats, we don't use the R in their book, but whatever, means the same thing. Okay. Anyway, so that's a sum of all the probabilities of outcomes in E. So anyway, with that, the complement. So thinking about complement, we learned first chapter. It's basically probability of, or it's how many were not in a certain Venn diagram or certain set. Same idea here. Okay. This means basically the probability of not being in E. Okay, which all that is 1 minus the probability of E. So say rolling a dice, say what's probability of getting a 6, that'd be 1 out of 6, right? Okay, what's the complement of that? Well, it'll be 1 minus 1 out of 6. So it'll be 5 out of 6. Okay. And then in general, anytime we have equally likely outcomes, so like rolling a die, flipping a coin, things like that, where the probability doesn't change throughout the experiment, if you kind of always keep this in mind, this is going to help you. All right, if I want to find the probability of an event, it's just how many ways the event can happen. So number of ways in the event, that's the numerator. How many ways it can happen divided by the total number of ways in our sample space. Okay, look at an example of that. All right, so example here, we're just flipping a coin twice. So very simple experiment, taking a fair coin, flipping it twice, and we're going to find this probability events. So if I want to find probability of 0 heads, so not getting any heads. So so again, basically what this means is this is the number of ways we can get 0 heads, how many ways that can happen, divided by the number of ways in our sample space. So in other words, number of total outcomes. Okay? So thinking about total outcomes, if I'm flipping a coin twice, I can get heads, 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 tails, tails, heads, or tails, tails, right? So if we look at that, there's 4 total outcomes, right? So 4 total outcomes. How many outcomes had 0 heads? Just one of them. So 1/4. Right? Again, that's something you could do. You don't need to use, all this formality to figure it out, but I think this is why we're using a simple experiment, or simple example here. Because obviously it's going to get more complicated. If you kind of just always keep this in mind, it's going to help you. All right. Next part, exactly 1 head. So probability person's calling me, I have to wait a second. Probability of 1 head would be, so how many ways can we have 1 head? Well, there were 2 ways, right? Heads, tails, and tails, heads. Number of total outcomes 4. Okay, you can reduce that to 1/2. And the last one, at least 1 heads. So count that up. There's 3 of those, so 3/4. Yep. All right, last example. Okay, if we've got a 10-sided die, all right, and we're labeling the sides 1 through 10, it's weighted, so the odds and evens are the same. Okay, or sorry, all the odds are the same, all the evens are then the same, but they're different probabilities between odds or evens. Probability of an odd is twice probability of an even. So I want to find what's the probability of getting an odd. So I have 10 sides, so I can just write W1 all the way up to W10. All those have to add to 1. All right? Same idea that we've used before. We want to just try to substitute so we get down to essentially 1 variable, because right now I have 10 variables. So if I know all the odds are the same, so that means 1, 3, 5, 7, and 9 are the exact same thing. All right, there's 5 of those. So I can just take all those and combine them and just say 5W1. Since 1, 3, 5, and 9 are all the same. I can do the same thing with the evens. So I can just say W2, because 2, 4, 6, 8, 10 are all the same. So I can say 5W2. Those add to 1. All right, so now I've got just 2 variables. And I can use the last bit of information. Odd is twice probability of even. Okay, so think odd, W1 was odd. So odd is twice even. Well, now I've got to make a little substitution. Okay, 2W2, put it in for W1. So I have 5 times 2W2 plus 5W2 equals 1. And I'm just going to continue this down below, different colors so you can see it. So that's 10 W2 plus 5 W2 equals 1. Got it to one variable, so now that means 15 W2 equals 1. Divide by 15, so W2 would be 1 over 15. So probability of even is 1 out of 15. Okay, make sure though, answer the question. The question is not even, it's odd. So if even is 1 out of 15, right, you can either use what we did here, or go back and look at the explanation. Odd is twice even, so if even is 1/15, that means the odd would be 2/15. And that is section 2.1. So I hope that went well. Ask me questions in class, please.